Okay, so the purpose of this video is to explain the first part of this question. So this is a sign hanging from a rod fixed to a vertical wall, metal wire attached between the rod, and the wall holds the rod horizontal. So what we have here is actually a moment question, because what we're asked here is explain why the vertical force exerted on the rod by the wire is 60 newtons. And let's show that question. Now, some of you might look at this and go, oh, this is a moment question. However, we haven't been given distances for essentially how long this rod is. So we're going to have to do this qualitatively to essentially explain how the principle of moments works for this question. So what we have here is a force that is acting at a distance from a pivot. This is going to be our pivot here. And we have another force, now, important word here, vertical, on the rod by the wire. So we can see where the wire attaches here. That force isn't vertical. It's anything but. This is vertical here. A line going up there would be a vertical force. Now, that's important in terms of the principle of moments, because it is that vertical force that's perpendicular to the rod and to the pivot that would allow a moment to be created. Now, this idea of moment is important because the force here times the distance here will equal a moment. The force here times this distance will also equal a moment. Now, the nice thing is that for this to be in equilibrium, these two moments, not the forces, but the moments have to be the same. So if you imagine this distance all the way across there is double what it is there. So imagine that as a value times by that would equal a moment. If you then double the distance, you would have to half the force to ensure you have the same moment in this case. Try putting some numbers in and see if you can see and demonstrate for yourself why that is the truth, but you need to explain that qualitatively here.